This is the last lesson in our unit on inequalities. Today we are graphing systems of inequalities. If you recall from our systems of equations unit, we will have two inequalities that we will graph on the same graph. And before we were looking at finding the point of intersection between the two lines. This will be a little more exciting because it's not just a point now, but there will be shading that is the answer to this system of inequalities. These are fun, but you have to take your time and pay attention. I'm going to graph these two inequalities on the same picture, noting where we would shade. So let's do the first one, the top one first. Top equation starts at -4. That's the y-intercept, and goes down 1 over 3. Now, because there's inequalities, you have to look at the symbol. There's no equal sign, so we would draw a dashed line. Then, of course, there's shading. So I look at the inequality. Its y is less than the line. So I would shade this one below the line. So I really lightly shade below the line. Very lightly. Don't do it very dark. I'll show you why in a second. Now I graph the second inequality. This one starts at 4 and goes down 7 over 3. Looking at the symbol again, there is not an equal sign, so this is a dashed line. Notice they cross. Okay, that's good. Now, which side of this line should I shade? Since it says y is greater than the line, I would shade above this line. So above this line is this way. Again, I'm going to shade really lightly. The part that is the answer is where there is double shading. So I shaded below this line, it's on this direction, and I'm shading above this line. So the part that's double shaded is this part down here, below this line and above this one. So you should see 3 shaded areas of your picture. 2 areas where we have single shading, and a third area where there's double. And you'll notice across from the double shading, you'll get a spot where there's no shading. So again, I think these are kind of fun. Let's do the second example. You start graphing the first line at +3. The slope is 1 over 3, so I'm going to go up 1 over 3. No equal sign, so this is a dashed line. And it's greater than, so I'm going to shade above that line. Remember, just do it lightly. The second equation starts at -4. I put the 2 over 1, so I know to go up 2 over 1. This line has an equal sign, so this is a solid line. Sometimes it helps on these to extend your line a little further off the graph. So I remember we shaded above the first line. Let's see where we shade on the second line. It says y is less than or equal to the line. So I'm going to shade below this line. I think you can see where we're going to get double shading is up here in the upper right-hand corner. So be sure you shade in extra dark on the spot that has double shading. So I have two zones that had single shading. Where they overlap is where I have double. That's the answer. And across from that, I should have an empty area. Now, what does this shaded area mean? Any point in this shaded area works in both of these inequalities. So on our first example, any point down here in the bottom right-hand corner in the shaded area works in both of these inequalities. It would make them both true. Let's try the third example. I start at -3, put a 1 under the -7. It means I go down 7 over 1. Now, going down 7 over 1 takes me off the page. So instead of down 7 over 1, I can go up 7, back 1. Since there's an equal sign, I draw a solid line. Since it's less than the equation, my shading is going to be below the line. For my second inequality, remember these are the ones that are like y equals 4. A straight line going through 4. But since there's no equal sign, it's a dashed line through 4. And for shading, I want y's that are bigger than 4, so I'll shade above this line. So I think you can see the double shaded area then is up here. So that means any point in the double shaded region would work in both of these inequalities. Points down here would work in neither of them. Points up here would work on one. Points over here would work in the other. This is the only region with points that would work in both inequalities. Let's do one more example. Start at -2, and then we go down 2 over 3. There is an equal sign, so this is a solid line. Its y is greater than the line, so I will shade above lightly. For my second equation, it starts at 4, and I go down 8 over 3. This one also has an equal sign, so it'll be a solid line. And for this one, it says I'm going to shade below the line, because y is less than the line. So I think it's easy to see this will be the double shaded area. So points in this region work in both inequalities.